Okay, we'll be quickly going through the review unless I'm stopped in order to do a more detailed answer. I've already told you about the PDFs being in Google Classroom. All right, this one would be growth. I'm just going to write a G or a D. This is growth, and this is decay. Okay. Any questions about that? All right, you only look at the B value. Don't forget this is the format. A times B to the X. B is what we're looking at, not the A. And then check if the exponent's negative or not. Okay, supply the y-intercept. The y-intercept is not a number, it is a point. It's a location. It's when x is 0, what is y? You need to write a point. So that would be 2, 0, 1/2. I'm going to do this concepts at once, okay? So I'm doing concept first. So concept of the putting in 0 for x. This one would give you a 1. Okay, because if you put in 0, you get 4 minus 1. The shift for this, there is none. The shift for this one would be horizontally right 1. And yes, I do expect horizontally. I still have some people who get horizontal and vertical mixed up, left and right mixed up with them. The shift horizontal left 2. That does say right 1, or I thought it did on the last one. And then vertically down 3. Okay, domain on all of them is negative infinity to infinity. Oops. I'm just going concept by concept. Okay, now the range on these does change. So your exponentials have a horizontal asymptote of the x-axis, so 0, infinity. This one is not shifted up or down, so 0 to infinity for the range, and the range has changed on the last one because it has a vertical shift down 3, so the horizontal asymptote went to -3, so it'd be -3 to infinity for the range. Okay. 8, to graph this function, you need 2 ordered pairs. You can get them off your graphing calculator if you like, and estimate where they are. You must show your asymptotes. If I put in 0 for x, I would get 1 plus 2, which is 3. That's a nice one to put in here. And then I would probably put in -1 because I'd like to do the reciprocal of 1/3, which would be 3, and 3 plus 2 is 5. So 0, 3, and -1, 5 would be very nice points to use. Knowing that the x-axis is an asymptote for our parent graphs of exponentials, I highlighted it to show it, and then I'm going to sketch that this comes down and then runs along the x-axis, showing correct end behavior. The domain's negative infinity to infinity, 1 second, and the range is 0 to infinity. Haley?
You want us to show
if it's just 0 and you just draw this and with an arrow, as long as you don't show me any dots on here, acting like it actually hits that, because I have students who make a point right there, and then that's wrong, and I'm going to mark it off. I'm not real, this is hard to show if you don't have a highlighter, so I understand that you may be thinking, trying to show it, so I'm not so thinking about that. But if it moves, it's got to be there. When? That's the, if it were, okay. I don't know why it's not. You know what I just did? A humongous mistake. Because I'm going too fast. You know what I just did? And I apologize, guys. Thank you for saying something when I totally did not even look at that 2 just now, except for when I plugged in numbers. I have no idea how in the world I did that. My key and right in front of me that I have on my left, I cannot believe I just did that. Well, Miss Heimer, that was a bad mistake. Okay. My points are right. Okay. The points I've got there are fine. The problem is I can't hit 2. Holy cow. I better explain this a little better. The +2, if you had a -1 up here, that wouldn't move it. But a +2 moves that asymptote vertically. I think I was thinking about logarithmics that plus 2 doesn't affect the horizontal, vertical asymptotes on a logarithmic. It does affect the asymptote here. This should have an asymptote at 2. So if you guys did that, and my apologies. Oh, went too fast. That has to be there. And I highlighted the wrong one. I just went on a rampage. Terrible, terrible, terrible. Okay, that passes through 0, 3, and then it turns. Okay, so the asymptote is 2, and that guides your range. 2 to infinity. Whoosh. Glad you stopped me sooner than later. That was a little later than I wish. Let me make sure that we think about this absolutely correctly. You see that plus 2 there? This is still an exponential growth problem or decay. Now, is this growth or decay? Well, the E is bigger than 1, so it is growth. All right, this is a shift horizontal. That would be your horizontal shift left 2. It is not going to affect the asymptote. Okay? Ooh. All right, X and Y. I know you guys can go in the graphing calculator and type this in and get some values. What I would think you might put in would be -2 if you were looking at these numbers, because that would give you e to the 0. E to the 0 would be 1, and you'd have a third. There's nothing nice about any of these points. They're all kind of gross. Okay, so that's about the only one you could kind of do in your head. If you put in 0, you're going to get 1/3 of e to the second, and that came out to be, when I went into the grapher, 2.46. And then if you put in 1, your table would say 1.67. Again, I understand that you guys can get something off the grapher, so just do that. Now, if I graph those, -2 and 1/3, and 0, 2 point something, and 1, 6, blah, blah, blah. This is coming up that way. Okay, it still runs along the x-axis, so it's domain, -infinity to infinity. You can put anything you want in, and the range is 0 to infinity. Do not include 0. Okay, that last one was decay because the b value was 1/3. Okay, this is a natural logarithm. So if I rewrote this exponential, it'd be e to the y equals x minus 3. To solve for x, you could say e to the y plus 3 equals x, and then you could find some points by plugging in values for y. They're not going to be real pretty. But this minus 3, since this is a logarithm function and normally it's the y-axis, it's a natural log, that minus 3 shifts this graph right 3, so your asymptote does move as a vertical line at 3. Okay. If I put in, what's going to give me a nice number I can't put in? I'll put in 0 would be nice for y, yeah. If I put in 0 for y, that'd be e to the 0, which is 1, and 1 plus 3 would be 4, so 4, 0 is a good point. Did anybody plug something else in? Like if you put in 1 for y, e is 2.718, blah, blah, blah. If you add 3 to that, that'd be about 5.7. Okay, so 5.71. So what's happening is this is coming up along the asymptote, then going through the x-intercept at 4, and then turning. Domain is from 3 to infinity. That switches. Now it's not the range that has the range is now the infinite, -infinity to infinity. Because the domain and range switch for an exponential function versus a logarithmic. We good? Okay, 11, when looking at, and this says when looking at it. It doesn't mean go look at it on a grapher. Just looking at this, Deanne says she thinks it must be growth since the base is greater than 1. She's calling this her base, of course, which is the growth factor. It's a 5. Well, she's wrong because 5 to the negative x actually equals 5 to the negative 1 to the x, and that is 1/5 to the x, and 1/5 is less than 1. The b value, you don't have to write that if you don't want. You can write the b value, or the base is it's actually between 0 and 1. This is a better answer, which makes it decay, so decay. Now, I've had some of you write it this way. You say b is, and you're writing it incorrectly. What did I see? I saw b, I'm trying to think of how you wrote it that I was bothered. I just had some people writing this inequality symbol the wrong direction, is my point. Okay? So just write it in words. It'd be easier. You don't have to have that, but you have to say something. So b is between 0 and 1, which is decay. All right. Moving on to 12. What's the transformation of the graph of f of x, y equals f of x to g of x is 5 to the x minus 4 plus 1. The 4 is a horizontal shift. So it's horizontal shift of right 4 and a vertical shift of up 1. Okay, the next problems are simply typing on a calculator. You were supposed to have done this review, so you're not supposed to be having, I hope you're not having to write everything down because your review's blank. I'm not going to be able to go slow enough for that. E to the 8th is 2,980.96. You guys can type these on a calculator, so 362.54, that's that one. The answer to 15 is x. The answer to 16 would be -3, and the next one would be -2, and this one is 1, and this one is 7. Oh, not 7, it's 10. I forgot. 10. Anybody need me to go further with these? I had someone ask me in my other class about 15. Yes. Okay, so I explained that that one is one of the rules that we wrote down, but it was b to the log and base b of x will always equal x. So if that matches there and there, then the bases are the same. The answer is the exponent is x. So here's another way for me to describe that. If I rewrote that, this is an exponential, is an exponent form. The log base 5 of x is the exponent. The base is 5. So if I wrote that as a logarithm, it'd be the log and base 5 of something equals the exponent, the log and base 5 of x. What would have to go in here, Scott? X. Okay? Rewrite the following as logarithmic or exponential, and that would be the log in base 5 of x is 4. And this one would be 2 to the x is 16, and it doesn't say to solve it, so don't write 4. Expand the log expression. This would be the, I shouldn't be writing in green on a green page. Log in base 2 of 3 plus log in base 2 of x. Next one should be the natural log of 10 plus the natural log of x minus the natural log of 3. And the last one there should be -3 times the log of x plus 4 times the log of y minus the log of 4 minus the log of y. Did anybody use parentheses anywhere in their answer? I need to know if it's correct. Okay, because if you put a parenthesis here, this would need to be a plus. It have to be changed from a minus to a plus. Okay? Because then you would need to distribute the minus sign. All right. We're good with the way I wrote it then? No questions about any of these? All right. Condense the expression. Now you're going to put 7 back on as an exponent, and this is subtracted, so y will go on the bottom. The natural log of x to the 7th divided by y. 26, you're putting back 1/2 on as an exponent. You could write the log in base 3 of 5 times y to the 1/2, or the log in base 3 of 5 times the square root of y. The next one, log in base 9 of 1/2. That'll be times the log of 4 to the 3rd divided by 8. Now, this can be simplified. 9 to the 1/2 is the square root of 9. You ought to know that. That's 3. 4 to the 3rd, you should know, is 64. And then we're dividing by 8. So simplified, this is the log of 24. Yes? If it's that easy to simplify, yes. Because these are numbers. You can't do it to these. Okay? Find the inverse. The first step when we found inverses, guys, what was the very first step for finding an inverse? Yeah, switch the x and the y. And some people forgot to do that. That's why I'm emphasizing it on the last quiz, and then they lost a point. All right, so now it's y is equal to, the base was 4, the exponent is x. That's it. Solve each equation, take the log of both sides, bring the exponent out front. Divide, x is just going to be the log of 16 divided by the log of 5. That is not simplifiable. You must just type it just like that on your calculator, and you would get the decimal. I gotta find where I am. I'm on 29, so that would have been 1.7227. This one be 5 to the 4th equals x. You exponentiate it, and 5 to the 4th is 625. Wait a minute. Is it? Yeah. Yeah, that's right. Do we have x equals 625 is fine. It's being solved. E to the 4th equals 8x. You're going to need to take e to the 4th and divide it by 8. That's going to be 6.82. Next one I would rewrite. You can do this multiple ways, but I would rewrite it. 16 is 4 to the 2nd. That makes this about as easy as you can. Instead of rewriting both of them in base 2, that can be done as well. You should get the same solution. Drop the bases. X is equal to 4x minus 6. Subtract 4x, negative 3x equals negative 6. You should have gotten x is 2, whatever way you solved it. Did anybody else do it in base 2? Yeah. It's still, did you get still good too? It's fine. Okay, number 33. We need to divide by 2 first. You have to isolate your logarithm. That's 3/2 or 1.5 if you'd rather write a decimal. Don't really care. Now the base is, we need to exponentiate it. So it's 10 to the 3/2 equals x minus 44. And then we'll add 44. So whatever 10 to the 3/2 is plus 44 is your answer. And that comes out to 75.6. The next one has one logarithm on each side in the same base, so you can drop the logarithms. So you got 2x plus 10 equals 4x. Subtract 2x and divide by 2 gives you 5. 35, when you look at that, the first step is isolate the natural log of x. You're going to subtract 1. Divide by negative 2 gives you positive 5/2. Exponentiate it. E to the 5th 5/2 equals x. Base is e. And that's just something you can type on your calculator. You can type e to the 2.5 or e to the 5/2. But whatever you do, it should be 12.18. Okay. 36, write an exponential function for each situation. Find each amount after specified amount of time. They're telling us what formula to use. Your equation shouldn't really have this the time number in there. It should have a variable in it. So the initial value, 1,275,390. Then that would be times 1. Our rate is 4%, 0.04 for our R value. And this was our A. And that'd be 1.04 when you add 1 plus 0.04. And that would be to the T. The population in 2005, now you're going to let T equal how many? Oh, it says, by the way, check that out. It increases by 4% per decade. How many years have passed from 1985 to 2005? Okay, so 20 years, you're not going to put in T as 20. 10 years is a decade, so this would be 20 divided by 10. So we're going to let T equal 2. So read carefully. All right, and this is number 36. And when I did that calculation, I got 1,379,462 people. Okay. 37 are at the top of 24A now. The value of a new car purchased for $18,500. That's not real expensive today. Decreases 8% a year. What's the value of the car in 4 years? So we've got to start with our initial value of $18,500 times 1 minus 8%. You can write it 1 minus 0.08 to the T. That is your equation. Now you should put in 4 years and do the calculation. And it should come out to $13,253.27. How many years until the car's worth $10,000? Put this equation in Y1, put this equation in Y2. That's why I tell you put a T in there, because if you don't put in the right equation, and some of you have gotten confused about why you weren't getting anything but a line. All right, because you didn't have a variable. All right, now, we have learned, though, enough at this point that we don't even have to do that, though. So we could solve it like this. Put 10,000 in for Y. And 1 minus 0.08 would be 0.92, right? You could actually solve this with algebra at this point because of what we've learned. So you would divide both sides by 18,500. What would that get you? 10,000 divided by 18,500. Someone give it to me. What's that? 0.54. Give me 2 more places. 5.5405. Okay, so here's where we would be at. And then you could just take the natural, I just use natural logs because it's faster to write. The ln of 0.5405 equals T times the ln of 0.92, and then you can divide those. So you can type this like this, and you can use LOGs or LNs, doesn't matter, logs or natural logs, they both will work the same. But what you should be coming out with is 7.4 years. Okay. Didn't say what to round to. All right, so you see how you don't even have to worry about if you don't know how to do it on the grapher. You can do it with logarithms. 38, you deposit your paycheck and it pays 3.5.035. Some people are writing their rates wrong with their decimals. Move it 2 places left. Your equation, you said how long till the balance triples. Now, if you want to do a tripling, just let your P be 1. Okay, 1E. You don't have to write the 1, but I'm writing it so you know what I did. And then T would be your exponent, all right? You could put the amount of 3 here, and then you could solve it by doing the natural logs. Okay, ln of 3 equals 0.035T times the ln of E. This is a quick one to solve without a grapher. Now, otherwise, you could put an A here, and then in Y2, put 3, and find the intersection. Okay? A couple of ways to find out if it triples. So if you do it where you're going to use the grapher, then you should have your equation used is this, and then you would put in y2, that's 3. Okay? Does that, everybody follow what I'm trying to explain? If it's quadrupling, it'd be 4. So if you're going to solve it algebraically, there's your equation right here. And you're going to solve for the time. So it should have come out, though, to 31.4 years, either way you do it. Okay, growth of a stock's value after its purchase in 1985 can be represented by this following equation. From looking at that equation, what was the value of the stock in 1985? Well, that's your initial amount, or P, $500. And the rate, careful, it's not 1.04, because 1 plus R is equal to 1.04. If you subtract 1, it's 0.04 is your R, and that represents a growth rate of 4%. Okay, do you want to write it as a percentage? I still need this. All right, 40. You invest $8,500. I know that's going in my equation. You pay 0.45, which would be 0.045 for your R. There's your equation, and it's compounded monthly, which is an N of 12. Okay, so the equation, 1 plus 0.045 divided by 12 to the 12t. Okay, don't put a 10 there yet. This is the equation. Now you're going to put in, find the amount in 10 years. So you pop a 10 in there now, push it on your calculator, and you should get, and if you did write the 120 there, I would not mark it wrong or something, because that's what you're calculating. But it is $13,319.44, what you should have got. Then it says, how many years will it take an account to double its value if it collects 5% interest, compounded quarterly? Okay, 2 ways to solve the problem. You can put in a 2 for doubling. You can put in 1 then for the amount in the account. And you can put in 1 plus, oops, not plus or minus. I don't know why I hit a minus there. There we go. 1 plus 0.05. Quarterly is 4 times a year. Divide by 4 to the 4 times t. I don't know what t is. So you may solve this one of 2 ways. You can take the log of both sides or the natural log. Oh, I would bring out my exponent out front. So I would have done 4t times the log of, and then I could have typed this in my calculator and found out what that is. And it's 1, I already did do it, 1.0125. And then that would be what you've got to divide by. So you're going to divide by 4 and by the log of t. So you could calculate it by doing log of 2 divided by 4 times 1.0125. Careful about your parentheses. You need it around the whole denominator if you're going to type that at once. And it's about 14 years. I think it comes out to 13.98 or something. 94? 95. So about 14 years is fine. All right, do you have money in 2 different bank accounts? I am, if you put these into your grapher, do you wanted me to do this one in the grapher? All right. Checking my time. All right, let's go. I think I already might have them in here. I do. Okay, so I've already got them typed in. Okay. Those are the 2 equations that were in the word problem. Then you would hit zoom 0. And mine is looking kind of cruddy. So I might want to adjust my window because it looks like the intersection happened way down below. And I don't think I need this 0, do you? I'm just going to adjust this a bit. Oh, that's one ginormous maximum, isn't it? I think I'm going to make that a little smaller. Oh, that's 100,000. Why'd I go that high? Okay. And I think I'm going to make this y 0. All right. Yours might, oh, what did I do to it? I can't see anything. Well, yes, I can. Good enough. All right. I'm going to go back to my graph. You can tell there's an intersection happening in here somewhere, right? Okay. So let's just do it. Get it to calculate it. Second trace, and yours might not look anything like mine. Just do second trace, enter 3 times, and it'll give it to you. Yes, oh, there it is. 11.3. So how many years will it take for the 2 bank accounts to have the same balance? That'd be 11.3 years approximately. And which account is better long-term investment? If you look back at your graph, the red one is, which is B, after 11.3 years. So what's your decision going to be based on? Depends on how long you want to invest, right? So you would make a description here. If I want to invest less than 11 years, then I choose A. If I want to invest for more than 11 years, then I would choose B. Okay, give me some kind of reason. All right, moving on. We got 2 different jobs. Got a base salary, 8% a year. This is going to be, again, something that you need to analyze and discuss on your own. If you're doing a job, it will depend on how long you want to work there, right? Okay. So if you're just going to start off working at McDonald's versus Burger King, then, you know, you're going to pick the short-term better one because you probably won't want to stay working there so long. But if you're going to go to some company that you have an interest in their what they do, which offers best? Let me just tell you that it's going to be after 4 years that Bugsy company or corporation exceeds the salary of Busy Bee. Okay, now that's when you put the graphs in, right? Put both of these equations in, see where they intersect, right? It's after 4 years. So your description again, it would be a better offer at Bugsy's if you want to work there over 4 years because the salary is going to be higher every year after the 4th year. Or you can say, oh, I probably won't stay in the job more than 4 years, so I'd take Busy Bee. Okay? Or you can total them up and give me a better description. Meaning, if you wanted to say, even do a more in-depth discussion, which I don't think you probably want to, you could make some totals and say, if I'm going to stay there 5 years, I still might need to stay at Busy Bee versus Bugsy, blah, blah, blah. All right, what type of equation is this? Well, E is approximately 2.718. I just happen to always memorize the 3 digits. Just sort of, and pi, you know how we memorize those. So that, oh, but that's a negative exponent. So what would e to the negative 3 do? That's going to be 1 over, okay, e to the 3rd to the x. So that's going to be tiny. So this is going to be decay. And the asymptote of this graph is vertical line at, or it's a horizontal, sorry. It's a y, horizontal line at y equals -2. Shift it down 2. I won't do the half-life problem. It's not on the test. And a population of bacteria grows X, has an initial population of 1,000. There's your P sub 0. Grows to 3,500. That's your P at T. And in 4 hours, of course, that's your time of 4. Write a function for the population of bacteria as a function of time. All right. So P of T is equal to 1,000 times E to the K times 15. Now we want to figure out our K, right? So this is the equation. Yes. I am going to do that now. So it said to write an equation as a function of time, which would be this. Now at this certain time, we have 3,500 in 4 hours. We're going to put in 3,500 equals 1,000 times e to the k times, oh, I see I had, this should have been a t, excuse me, k times 15. Yeah, I should have left a T in there too. Okay, and I don't care if you didn't even write this one out in the very beginning. That's not a problem. You're going to be solving it. So what I got to do now is divide by 1,000, which is going to give me 3.5 equals e to the 15k. I'm just flopping those around. Then I'm going to take the natural log of both sides. So the natural log of 3.5 equals 15k times the natural log of e. Natural log of e is 1. So the natural log of 3.5 divided by 15 gives us our k value. And that's 0.3132. Okay, now what you do is you write an equation now. Then you can plug in the end of, oh, holy cramoly. You know what I just did? This is the right answer, but change those 15s to 4s. The stupid put in the 15. I'm trying to rush. I want to make sure I got everything done, and I'm rushing. 4 should be the number we're putting in. It was 4 hours, everybody, right? That was the initial amount. Sorry about that. No, that's how you're finding your K. Okay, it's got to be a 4 here. All right, now after I find my K of 0.3132, which is what you're going to get when you type this, ln of 3.5, go ahead and recalculate it if you want, divided by 4 will be 0.3132. Okay, the new equation for any amount of time now, and we're going to do the P of 15, we're going to be putting in 1,000 times e to the 0.3132 times 15. That's the new calculation you need to make. Caught myself there. All right, so we got a lot of bacterias. 109,727 bacteria. Okay. And then the one more question I want to make sure we go over for sure on the test is the last one. You are going to be required to do one of these, and you're going to have to graph it. You're going to sketch a graph, and you're going to have certain things on the graph. I'll just make it down here. Well, I just want a straight line, so I'm going to do. Okay, so it tells you to graph this. You got to pick some numbers. It says graph a function for the time between 0 and 1,000. That would be on your x-axis. What's the initial population? Well, that would be the y-intercept, and we need to figure that out. Okay, what's the max population? That's given. It would be the part of the equation that has the ceiling, the number on the top here, 18,500. So I need to have, that's my asymptote. You need to show that that's 18,500. Then you need to pick what you want your range to be. I have 0 to what? What do you think? What should the top be? 20,000 would be fine. You could do 19,000 if you want. It's just got to be something bigger than that, right? So say I did 20,000 just for simplicity. Not 19,000 is any harder. We go to our y equals. We clear out this stuff. And I think it was 18,500. Oh, I have it in y2. Who cares? It'll just be red. Divided by, and then can you guys tell me, parenthesis, I can look quick, 1 plus 12 times e to the, all right. What? I'm going to just give the answers quick, but what did you just say? I have what? I did. I had an extra 0. Oh, okay. So what's this thing do? It goes like this. Okay. And this number, you should find the y-intercept is 1,423. Okay. And it takes about 499 years till it gets to 15,000. You don't need to have a right to line up, by the way. You should have stayed in your seat. Thank you.